So this is the first video I'm going to be doing for this channel. This is an intro to limits. This is your first video that you'll be seeing. Let's get right into it. So what is a limit? A limit is basically the y value that a function approaches at a particular x value. So for example, here we have f of x equals 3x plus 2. So the limit as x approaches 2 in this case is going to be 8. We can see that on the function right there. You can see that as the function moves towards the x value of 2, it's going to be approaching the y value of 8. There is a difference between a limit and an actual function. So we have, okay, let's start off right here. We can see that limit is written as limit x approaches a, f of x equals L. And there's a difference between that and just f of x equals y when you write a function as is, which you've probably written a lot before. So yeah, this is the difference. So let's take the function g of x equals x squared minus 9 over x minus 3. We see that there's actually a hole at the value x equals 3. But we can see that even though the value is undefined, the limit actually still approaches 6 because the limits do not depend on if a function is actually continuous at a particular point. It's just seeing if the actual function approaches that value from both sides. So this function, you can see, still approaches the y value of 6, but it's not actually equal to the y value of 6. So basically, when the left and right sides do not approach the same y value, the limit does not exist. Here is that example of that. So this is when there's not a hole, like the last one had a hole, that was the same value from left and right. But if you have a function like h of x equals 1 over x, the left and right sides do not approach the same value, so the limit is also undefined. You can see the actual function is undefined, limit is undefined, but instead of undefined for limits, we write DNA, which is, sorry, DNE. DNA is biology, oh my goodness. DNE, which stands for does not exist. So here are other limits that fail to exist. You have different behavior from left and right. We already kind of covered that, but that also goes for things that look like that, where it's like a hole and then it continues again at another point below. That's mostly for piecewise functions. The middle one, unbounded behavior, is just when it shoots up and it has a vertical asymptote from both sides. It'll shoot up to infinity, but it never really actually connects at a value in the middle. It just shoots over to infinity. And the last one is oscillating behavior. By that, I don't mean sine and cosine, because that one you can easily find limits. I mean like a function where it starts squiggling so much that you can't really pinpoint what the y value is. So that's the example right there that I have. Yeah. Thanks for watching this first video. Hopefully this was a nice intro or a nice review for your quizzes or whatever. Yeah. See y'all later.